Okay, for this first one, obviously you're only picking three, so it didn't really matter which one you picked. What's this part? What's this one right here? What's the concrete shield do? It shields for, yes, neutrons. It shields for neutrons. And what's this one? This one here? That's the lead shield. What is it shield for? Gamma rays. I don't need to shield for anything else. Just those two things. How about this thing right here? Control rod. And what's it do? It's the thing that turns off the reactor, shuts it down. Doesn't need to be an emergency. Maybe I just need to turn it off. I don't need to use it right now. So you just put those things in and it turns off. How about this one here? Pressurizer. What's that one do? Make sure the pressure is high enough to do what? Boil, not let the water boil. So steam is a terrible heat conductor. And remember, one of the purposes of the primary coolant was to pull heat away from the nuclear reaction. So I need it to be a liquid. So what I do is I pressurize it to 2000 psi to make sure that even though it's at 500 plus degrees Fahrenheit, it's still a liquid. How about this one here? The reactor vessel. It's where all of the nuclear reaction and nuclear material are housed. That's the pressure cooker portion of the assembly. And then how about this thing here? The fuel assembly. And how about this one here? The fuel rod is, or the fuel assembly is where all the fuel rods are, and then each one of those individual rods is where the nuclear material is held inside of that. This guy here? No, that's not an emergency pump. That's just primary coolant pump. There is one, but it's not shown. How about this one here? Steam generator, which does what? Don't say generate steam. It brings in the hot primary coolant and allows the colder feed water to be evaporated into steam. This keeps the liquid that touches the rods that have the radiation in them separate from the liquid that turns the turbine. So this is the point where nuclear stuff stays segregated from the non-nuclear stuff. Yeah.
You say it's like a transfer of the energy from the hot liquid to the cold.
Sure. Sure, that's fine. And then this down here is the feed water. So that makes this guy here the feed pump. And then this one here is the turbine. Oops. the steam hits the turbine and spins the turbine, and the turbine is mechanically connected to the generator. So once the generator starts spinning, then you produce the electricity. So here's my generator. And this is my condenser. And the condenser takes the spent steam and turns it back into liquid, because I can't heat steam very well, but I can heat liquid really well. So that makes this the condenser pump. Both of these are the cooling water pumps. I think that's it. So why is it going to be difficult for a leak to reach the river? So all of the radiation is right here, inside of these rods. So the first thing that would need to happen is these rods that have the nuclear material inside of them, the rod itself would have to crack open. And then that would leak into the primary coolant. And so then all of a sudden there'd be radiation in my primary coolant. But that doesn't cause a leak, right? I'd still need to break this here, the steam generator. And then all of a sudden I'd have radioactive steam going through here and then liquid. And then I would also need to break the condenser, and then that would have to get fed into the condensing loop. And then it would be all through the loop here. And then the condensing loop would actually have to break too. And then I could finally get nuclear material into the river, lake, whatever it is, ocean. The only way this happens is if there's a catastrophic failure and everything is broken at the same time. So, giant earthquake, and you're right next to the water. So you'd have to break the rod, the steam generator, the condenser, and the cooling tower, and stuff would have to still be pumping. Well, the safeties, that wouldn't matter, because if this here broke and that broke, all these things broke, then it doesn't matter if the control rods go in, you still have radiation leaking out. How about coming out of the top of the cooling tower? No, you can see it. If you can see it, it's not steam, because you can't see steam, because steam's a gas. So you're looking at a cloud, say water vapor, whatever you want to say, but it's not steam. All right, how about this last one here? Did we find out what that meant? Okay. Some dude with an axe has a control rod.